Assalamu alaikum everyone, this is me Shuhaib, and in this video I will show you how you can perform short circuit test or full load test in a transformer. So we already know that we know two types of experiments in a transformer. One is open circuit test or no load test, and another one is short circuit test or full load test. So we are doing this short circuit test, or you can say full load test, in this experiment because we want to find the copper loss component. We do open circuit test or no load test for the core loss component, but to get the copper loss component we have to do this short circuit test. So in if I draw the circuit diagram, then it should be like this: core, primary, secondary. Yeah, that's it. So we have to make the experiment or make the test in the primary side, and we have to short the secondary side like this. Why we are making this secondary side short? Because our target is to make the current flow at maximum, because we have to get the copper loss in total. Current won't be flow more than the rated or more than the maximum, so the maximum copper loss we will be able to get when we make the secondary side short. Okay, then our target is to provide the current at its rated value in the primary side, then we will be able to make the experiment. So we, let's say, give these ratings, I mean these components, like this and this. Okay. So when we provide rated current in the primary side, we have to neglect this portion, because a high current will flow in this circuit compared to this part. Okay, so the circuit should look like this one, something like this one. Okay, that means no current will flow in this circuit, in this portion we have to take like this, and the rest of the circuit should look like this. Secondary is shorted. Okay, so let's say this is R1 and then this is X1. So another important topic is that, you know when I will flow the current in this side IS and measure the power. Okay, we are measuring the power with a wattmeter. Then this wattmeter will measure the power consumption in both P side and S side. Okay, but we have this P side component only. So one important modification should be done, like we have to consider the secondary side components. So we have to take these components at this side. Okay, so after these simplifications we will have the equivalent resistance R. Let's say Req. What is Req? Req is the R1 plus R1 prime. And what is R1 prime? R1 prime is the resistance of the secondary side at the primary side. That means this R1 prime will be shown the resistance of the secondary side in the primary side. That's it. I hope you can understand that. Same thing will be done for the reactance. Let's say X equivalent. Okay, because we have to consider the secondary side reactance also. Then we can simplify the circuit like this. We have this input current IS, and and so on. But an important topic is missing so far, that is, we have that transformer also, like high voltage side and low voltage side. Okay, so which side we should take, primary or secondary? I have already told you that we have to make this high current at its rated value. So to get this rated supply current, it is easier to get it from the high voltage side, because in the high voltage side rated voltage is high compared to the secondary part, compared to the other side part rated current is low compared to the other side. This is low. So our target is to get the rated value, and in the high voltage side it is easy to get the rated supply current. So the primary side should be high voltage side and the secondary side should be the low voltage side. That is. So let's go to the experiment now. Then to get this supply current we have to provide the voltage, right? Obviously without voltage how can we get the current? And this voltage can be measured by the voltmeter, and the current will be measured by the ammeter. Okay, and then we have to measure the power by a wattmeter. This wattmeter always gives the real power value. So now we will get the numerical values, but if we look at the equation, then the equation is W is equal to Vs Is cos theta. What is this cos theta? Cos theta is the power factor angle. So at very much first calculation we can get the power factor, which is cos theta is equal to W divided by Vs divided by Is. Okay, so now it's our turn to get this R equivalent circuit. You see, in the whole circuit Is is same for the R equivalent or for the X equivalent. So Is is same for all of the components because this is a series circuit. So W is equal to Is square R. Simple. So from this equation, actually R equivalent, we can get the R equivalent, which is R equivalent is equal to W divided by Is square. Okay, that's it. Now how can we get this X equivalent? We have already found that R equivalent. Now how can we get X equivalent? You see, if we calculate, then the whole things makes Z equivalent, and this supply voltage is applied across this Z equivalent, right? And we have the current Is. So the Z equivalent will be Vs divided by Is. Then we have Z equivalent, and if we can get Z equivalent, then we can easily get X equivalent, like Z square minus Z equivalent square minus R equivalent square. So we have found the X equivalent. Okay, so we have already found the real power like this, and we can also find the reactive power, like, you know, if we take Q, then Vs Is sin theta, because we have this cos theta, and from this cos theta we can get sin theta. So it's easy. So you know, we have just got all of the things which we need in short circuit experiment. We have R equivalent, X equivalent, Z equivalent, real power, reactive power, power factor, everything, so on. We can also get the voltage drop across this R equivalent or this X equivalent as well. Okay, so this is it for now, and let's see you in the next video. And if you have any questions for any video or in this video, just do it in the comment section. Bye bye, see you later.